Every Hot Wheels car zips down a track because somewhere, a designer fought three ruthless limitations. It must conquer loops, survive hard play, and cost almost nothing to make. A fraction of a millimeter can mean success or total disaster for the world's favorite $1 toy. Why do billions of these cars work so perfectly when even small errors can ruin everything? This is where that story begins. A Hot Wheels designer leans over a crisp sheet of paper, pencil in hand, sketching the first lines of a new car. Some days it is a real-world legend, maybe a Ford GT or a Ferrari licensed down to the last curve. Other days it is pure imagination, engines bulging, spoilers soaring, a fantasy machine built for speed. But every curve and angle faces the same trio of rules. The car must whip through a loop without flying off the track, stay safe enough for a toddler's grip, and cost pennies to mass produce. These constraints shape every decision, from the width of the fenders to the height of the roof. Once a sketch passes muster, the process moves from pencil to screen. Designers sculpt the car in three-dimensional computer-aided design software, locking in dimensions with ruthless precision. A wheel just half a millimeter too wide could jam in a curve. A roofline too low could make the car fail a drop test. The software becomes a battleground, balancing the wild ideas that define Hot Wheels with the cold math of manufacturing. Licensed models often bring their own headaches. Brand guidelines demand exact body lines and logo placement, sometimes forcing last-minute tweaks that ripple through the whole design. Throughout, culture and history nudge the process. The iconic twin mill, first drawn in 1968, still influences the look of modern fantasy cars. Even today, designers talk about making a car that looks fast, standing still, a phrase that echoes through decades of sketches and digital blueprints. By the end, what started as a daydream on paper becomes a digital model, locked to the millimeter, ready for its first real-world test. A prototype engineer loads a fresh 3D print onto the test track. The plastic shell looks almost identical to the final car, but every detail is under the microscope. A single run can reveal what the CAD model cannot. A wheel that scrapes the edge of a loop, a roofline that clips the track, a base that sends the car wobbling instead of shooting straight. The engineer notes the results. Wheel diameter off by half a millimeter, axle position shifted by a fraction, maybe 0.2 millimeters. These are not guesses. Digital calipers and slow-motion footage capture the smallest flaws. Back at the workstation, the CAD model gets another round of edits. The wheel wells widen by just enough to clear the orange plastic. The base weight shifts forward, chasing that perfect balance between speed and stability. A few hours later, a new prototype emerges from the 3D printer. The cycle repeats. Track test, measurement, tweak. Each loop through the process shaves away uncertainty. 5 different types of 3D printing come into play, some for ultra-fine detail, others for quick, rough models that can be crashed and abused. The goal is always the same: find every weak spot before any steel is cut. Only when the prototype rockets through loops, clears jumps, and rolls straight every time does the engineer sign off. The digital file is frozen, the geometry locked. Now, and only now, does the design move to the tooling team, because once the steel is carved, mistakes get expensive. Deep inside the factory, the tool-making shop hums with a different kind of energy. Here, a block of hardened steel becomes the heart of every Hot Wheels car. The process begins with a CNC machine, its path guided by the final digital model. Each pass of the carbide cutter carves out the negative shape of the car's body, down to the smallest ridge or badge. Even the tiniest error in this stage could ripple through millions of cars, so every contour is measured and remeasured, sometimes to within 1/100th of a millimeter. Once the rough cavity is milled, toolmakers switch to electrical discharge machining, known as EDM. Sparks dance between electrode and steel, vaporizing metal where cutters cannot reach. The result is a cavity as precise as the digital file, ready for the next step. Cooling channels wind through the mold, invisible but essential. These passages carry chilled water during production, keeping temperatures stable and preventing warping or cracks as molten metal fills the die. A toolmaker, sleeves rolled, inspects the cavity with a jeweler's eye. He says this mold will make over 1 million cars, running a finger along the polished surface. If we get it wrong, every car after is wrong too, he adds. The mold's lifespan is measured in millions of shots, its cost spread across countless runs. Weeks of labor and six-figure investments are justified by this endurance. When the cavity shines like glass and every edge passes inspection, the die is ready for the next phase, the trial by molten metal. Inside the casting hall, the heat is relentless. A technician checks the readout on the furnace, where liquid Zamac alloy, a blend of zinc with a dash of aluminum and copper, swirls at nearly 400 degrees Celsius. That is the sweet spot. Too cool and the metal will not flow. Too hot and the mold wears out before its time. The die casting machine stands ready, a pair of steel molds clamped tight, their surfaces gleaming with a thin coat of lubricant. With a nod, the technician signals the cycle to begin. A plunger dives, forcing molten metal through a gooseneck channel and into the waiting cavity at immense pressure. In less than 1 second, the alloy fills every ridge and contour, door lines, fender flares, even the tiny logo on the hood. Water channels inside the mold keep the steel just cool enough. As the metal sets, the machine hisses and the die splits open. Gravity does the rest. A multi-cavity sprue, bristling with 6, sometimes 8 raw car bodies, drops onto a steel tray. The castings are still hot, but already solid, miniature skeletons of speed. Excess metal, the sprue and flash, is trimmed by a press that stamps down with a clean mechanical thunk. Nothing goes to waste. Every scrap of clipped metal is swept back to the furnace, melted again for the next shot. The technician watches the output, eyes sharp for any flaw, a bubble, a short shot, a warped roof. Each cycle is a dance of heat, pressure, and precision, repeated thousands of times a day. On this line, the raw forms of Hot Wheels are born, ready for the next round of shaping and shine. Clear plastic pellets tumble into heated barrels, melting into a syrupy flow that is injected into steel molds. The result is perfectly transparent windows, ready to become windshields or sunroofs. Nearby, colored plastic forms the interior tubs, seats, dashboards, every detail molded in a single shot. Wheels emerge from another line, their hubs crisp and glossy, waiting on trays. While plastic parts cool, metal bodies queue for their transformation. Each one is washed, dried, and then enters a spray booth where robots lay down up to 5 coats: primer, base color, metallic flash, and a clear gloss that catches the light. Tampo printers follow, pressing stripes, flames, or tiny logos with precise rubbery pads. A technician glances down the line, watching for any misprint or smudge. By the end, every car body gleams, painted, printed, and ready to meet its plastic counterparts on the assembly line. On the assembly line, every part finds its place in a precise order. The painted metal shell receives its plastic interior, then windows snap into position. The base clicks underneath, locking everything together. Steel axles slide through their channels, wheels crimped on tight so they spin freely but never slip off. Each finished car faces a final test, a roll down a measured track. If it veers off course or a wheel sticks, a gloved hand lifts it from the line and drops it into the recycle bin. Only the smoothest rollers move on. Workers pack them, one by one, into clear blisters sealed on cardboard cards. Boxes fill, pallets stack. The scale of it all becomes clear. Hundreds of millions each year, billions since 1968. For a child or collector, that tiny car is just the start of the story. Every second, nearly 16 Hot Wheels roll off production lines, a reminder that even in a digital age, physical play endures. As manufacturing evolves, the balance between mass production and imagination shapes what childhood looks like. Sometimes the smallest objects leave the biggest marks. What do you think drives their appeal?